If you'll indulge me, I want to take another couple of numerical examples. Let's say someone comes into that office with a mean of 65. They're at 66. Now, one thing I want to tell you about 66, 66 is close to 65. It's just an eyelash above, and the z-score reflects that. 66 minus 65 divided by that standard deviation of 3. And sure enough, it's a z-score of about 1/3 above. Let's say I told you, hey, somebody came in and they were 1 1/3 standard deviations below the mean in age. Now, this is where it gets a tad awkward. I would say 65 plus negative 1.33, which is a little awkward because we're saying plus negative. So in effect, we're subtracting, but you can sort of keep track of that. 1.33 times 3, let's call it roughly 4. So 65 minus 4, 61. So I could go either direction, and for our purposes, that's kind of enough to know. I'm not super concerned with the math here. We got plenty of space for math in chapters 6 through 9. But I do want to introduce the basic concept that we can express whether or not someone is above or below the mean with a z-score and the degree of magnitude. 1 standard deviation above, 1 1/3, 2, 2.1, 0.7 standard deviations below. And although in isolation you really can't appreciate the magnitude just from those numbers, when we get to chapter 6 and begin using tables, you'll begin to see that if something's 3 standard deviations above the mean, it's well into the 99th percentile. And even 2 standard deviations above the mean is, about roughly the 98th percentile. And conversely, if it's 2 standard deviations below the mean, it's only at the 2nd percentile, which means that only 2% of scores fall below that. If you were 2 standard deviations below the mean on something negative, it'd be good. Just like we mentioned the bad cholesterol, and I forgot what it has a name. I'd love to hear that. I'd love to get that kind of news. That would suggest I have a good diet and everything's going well with my bloodstream. So here's another example. A 12-point distance from where we have a mean of, what is the mean here? The mean is 46. So the standard deviation is 4. Let's just take that for granted. So I have a mean of 4 and a standard deviation of 46. Where does 42 fall? Well, that'd be a z of negative 1. Where does 54 fall? Well, that's a z of positive 2, as you can see. So they left off the positive numbers, but you can sort of figure that out. And, we can begin to assign ranks. So, what is 42? Maybe that's another age at which something falls apart. Who knows? But you can see these, magnitudes, and you can also easily convert almost in your head, but you never have to convert in your head. I almost enjoy it, but others don't like math very much, and you can always use the formulas. We'll get back to this in a second. I want to talk about this idea of transforming, but also want to talk about what a transformed distribution looks like.